Today we're going to be talking about multiple linear regression with qualitative information in the explanatory variables. Multiple linear regression with qualitative information. In the explanatory variables. So to put some things in context, so remember that so far we have only considered explanatory variables that had like a quantitative meaning. So far we have only consider x's, explanatory variables with quantitative meaning. So remember, in our model here, what I'm trying to say is our multiple linear regression model. All these explanatory variables, all the x's, have been quantitative or had quantitative meaning. Okay, so for example, some of the cases that we have talked about, some of the examples that we have talked about, we had as explanatory variables. We had prices. We had lot size. We're looking at the factors that affect the price of a house. We had the number of bedrooms. We had education in years. And so on and so forth. So that's the type of explanatory variables that we had. They all had kind of quantitative meaning. Now, it's also possible, to have as explanatory variables some variables that actually denote qualitative information. So it is also possible. It is also possible to have explanatory variables that contain or that denote qualitative information. For example, we can have gender, male, or female. So, we can have region in the country. So we can have northeast, we can have south, west, and midwest, or east. Well, let's say we can have east just to have it. East, south, west, midwest, and so on and so forth. You can add more regions here. Okay. So the other example could be, for example, education level. We can have elementary school education, high school, and college. Okay, so as you can see here, in some cases, we're interested in looking what's the effect of these qualitative factors on an outcome, on a dependent variable y. Okay, so y still we're assuming that that's also quantitative, but we're talking about the possibility of having some explanatory variables that denote qualitative information. Actually, there are some other models where actually even y can be contained, qualitative type of information. But for now, we're only concerned about including qualitative information as part of explanatory variables in our regression model. Okay, so as you can see here, when we're talking about qualitative information, we have, qualitative information. Basically, this qualitative information, one way to think about it is that, these individuals, they belong to different groups. So for gender, male and female, here in our example, we had 2 groups. For regions, I had written 4 groups, and for education, I had 3 different groups. Okay, so now let's start. To start with analysis, let's talk about qualitative information that qualitative information for 2 groups only. So let's say, explanatory variables, qualitative information. Let's say qualitative explanatory variables. Denoting information about 2 groups or categories. Okay, and to talk about that, we need to define what's called binary or dummy variables. It's binary, sometimes called dummy variables. So, and the idea here is that these, binary, dummy variables are variables that are defined with 0s and 1s. So variables that can be defined using 0s, using 0 and 1 to denote the category. So to denote the 2 categories. An individual belongs to. Okay, so a binary dummy variable is a variable that can be defined using 0 and 1 to denote the 2 categories an individual belong to. Now, before I move on, so remember when here I'm talking about the individual, individual can be a person, of course, but it can be a city, it can be a city, can be located in the north, the south, or a state, the same thing. So individual refers to our unit of observation. Okay, so this type of variables are what are called binary or dummy variables. And one way to think about these binaries or dummy variables is that we're using this 0 or 1 to go from the qualitative information to the quantitative information. So these dummy variables zeros and ones are used to go from the qualitative information to quantitative information. So one group, we're going to give the value of 0 to one of the groups or one of the categories, and we're going to give the value of 1 to another category. So we use for group 1, category 1, we use 0, and for group 2, category 2, we use a 1. So you see that's the way that we go from qualitative to quantitative information. So just some other examples of these qualitative explanatory variables denoting information about two groups and categories. So let's look some other examples. So qualitative variables with two categories. If I was in class, I could be asking you to give me some examples. I already mentioned one. This is gender. We have male and female, so that's biological gender. We can have something like computer ownership. Okay, so that's going to be a yes or a no. Now everybody's talking about access to the internet. That will be another one with a yes or a no. We can talk about, for example, some of you are close to graduation, college degree. We again could be yes or no. Okay, so as you can see, all these qualitative variables with two categories. We could use these zeros and ones, these dummy variables, to denote this information, this qualitative information, using numbers. Now, something that's going to be very important, when we use these dummy variables in the context of regression analysis, is that we are going to have to decide which category is assigned the value of 0. And we're going to give that category what's called the base category, and which category is assigned a value of 1. So it's very important to have in mind which is the base category and which is the base category, and we call that the other category, because for interpretation purposes. So in defining a dummy variable, we must decide which category is assigned the value of 0. So that's very important. In this category, this is going to be called the base category. Okay, so the variable that takes the value of 0, the category that takes the value of 0 is going to be called the base category. Okay, and of course, by default, the other category is the one that takes the value of 1. So let's see how does that work. So, for example, you see, if we're talking about gender, notice that we have two options to define our dummy variable for the variable gender. So we can have female as 0 and male as 1. So that means that females is the base category. Okay. Or we can have female equal to 1 and male equal to 0. And then in this case, the base category is going to be male. Okay, so it's very important to define that, and that also, hopefully, helps you to see how, with these qualitative variables with two categories, we can use the 0 for one of them, and the one for the other, but it's important to have very clear which is the base category. Okay, so now that we hopefully you have an understanding on that, the possibility of including this qualitative information, and specifically initially we're talking about qualitative information referring to information about two groups, the use of dummy variables, which means that you use zeros and ones for the two categories, and then the fact that we need to define very clearly which is the base category, which is going to be the category that takes a value of 0. Then we can talk about the use of a dummy variable in linear regression. So dummy variable. Linear regression. So I'm going to write the model, and I'm going to write it just like a simple linear regression model initially. And I'm going to use a delta instead of using a 1, a beta 1. So this is kind of like a delta to differentiate it, from what we were using before, but this is just a matter of definition. So you notice here that x, can take the value of 0 or 1, so x is a dummy variable. Okay, so remember, since x can take a value of 0, 1, if you are thinking in terms of Excel, if you had an Excel file, think about y as the price of a house, and delta like a house style, like a modern or old house style. So you're going to have zeros and ones in your column for x, for your dummy variable. So, and then, to go, for estimation is going to be exactly what we did before. So, again, what you're trying to do is you're trying to minimize the sum of square residuals, and you are going to get these coefficients as part of the output of in regression analysis. So, when we're talking about dummy variables in linear regression, estimation is the same as before. Okay, so that has no change. However, what it does change is the interpretation of that coefficient. But the interpretation of the delta coefficient is different. Okay, so you have to be careful. You have to be careful about that. Okay, so to see how is that we go about interpreting this coefficient, so let's go about. So remember, so this is our linear. So this is our regression model. So let's get rid of that of the error term. Remember, we're going to write our population line. We can write it at the expected value of y is equal to beta naught plus delta x. Okay, so now let's do the following. So let's calculate the average value of y when x is equal to 0. Okay, and then we'll also calculate what's going to be the average value of y when x is equal to 1. So when x is equal to 0, the way to calculate this thing, we just substitute it there, so you are going to end up just with that intercept. Okay, and when x is equal to 1, we're going to have beta naught plus delta. Okay, so I'm going to write down here. So remember, here what we have in this expression in words, so that's the average value of y for different values of x. That's what the way to read that expression. So what we have here is going to be the average value of y when x is equal to 0. Remember, that's the way that we define the expected value. So that's the average value of y when x is equal to 0. So if you think about that, that basically is the intercept. Okay, so it seems that the definition of the intercept has not changed. So remember, beta naught still is going to be the average value of y when x is equal to 0. So that's same as before. And now let's see this term. So this is going to be the average value of y when x is equal to 1. Okay? So now let's see what's going to be the difference between these two averages. So if we subtract the average value of y when x is equal to 1 minus the average value of y when x is equal to 0, that is going to give us beta plus delta minus beta naught. So that's going to be equal to delta. And this result here, encapsulates or kind of summarizes mathematically the way that we go about interpreting that coefficient related to a dummy variable. Because you see, as you can see here, this delta then is going to represent the difference in the average value of y when x is equal to 1 and the average value of y when x is equal to 0. So delta represents the difference in the average value of y when x is equal to 1 and the average value of y when x is equal to 0. Or another way to think about that, remember that delta, so the coefficient related to a dummy variable, represents the differences in the average values of y. Now, to make things easier, sometimes, the way that we go about, and this is kind of like the formula that you can use when you are writing interpretations. So when interpreting delta, we can say that relative to the group represented by x is equal to 0, the average value of y when x is equal to 1 is delta units. Yeah, and it could be delta units higher if it's positive, and negative if it's lower. Okay, so this thing probably then at this point, you will see how to apply this definition later on when we're using a specific example. But the thing to remember so far, this thing probably is going to become a little bit clearer when we have a specific example. The thing to remember here is probably what we have here in this expression is that delta represents the difference. It's a difference in the average value of y when x is equal to 1 and the average value of y when x is equal to 0. Okay, so that's kind of the key concept. In the context of this model where we only have one dummy variable, the intercept is the intercept. So that's the way that we define it. And so the next thing to do would be to use these concepts within the context of a specific example, and you will see better probably how all these definitions work in the context of a specific example.